I'm Mike James, and in this tutorial I'm going to use the calculator to graph a function. In this example we're given two functions, f of x equals 2 minus x squared, which is a quadratic, and g of x equals sine e to the x, and they're both given in the same domain, x between minus 2 and plus 2. Now the graph of f is drawn already. It's a parabola, as you'd expect from f of x equals 2 minus x squared, and we've got to graph g of x equals sine e to the x, which is quite a complicated graph, so I'm going to make use of the calculator. Now I'm going to go into graphs view, and I'm going to enter 2 minus x squared straight away, because I'm going to need to graph that for the later part of the question. And there it is, it's the parabola, the quadratic. I'm going to just move this out of the way, and I'm going to hit tab and graph the second function, which is g of x equals sine e to the power of x. Now before I graph this function I need to really make sure I'm in radians, so I'm going to just check that. And graphs and geometry, yes, I'm in radians, that's fine. So let's keep this in radian mode and not degrees, and I'm now going to enter the graph of sine e to the x. Brackets are quite important. I'll hit the e to the x button and press enter. And there it is, that green graph. Now it's all a bit cramped, so I'm going to adjust the scale. I'm going to make x minimum minus 3, for example. Tab to x maximum, make that plus 3. Tab down y minimum, make that minus 2. And y maximum, make that 3. And tab to OK, hit enter. That's a bit better. Now I can see the second graph, which is in green. So I can see it quite clearly, and all I need to do now is copy this as accurately as I can onto the grid. So it's a bit easier for you to do in pencil than for me to do on the computer. Okay, let's move on to the second bit. It says solve fx equals gx. So basically we want to find the x values where these two graphs actually meet. So let's go back to the calculator. So we've got to find these two x values at the points of intersection of these two graphs, and you can see they intersect at 2 points. Now to do this you need to hit menu, go to analyze graph, and then go to intersection. Now you'll see lower bound come up. You'll also see a vertical dashed line that you can drag left or right, or you can use the left arrow button to move it and the right arrow button. So I'm going to make sure the vertical line is to the left of the first point of intersection. Then I hit enter, and you can see I've got upper bound. Now I'm going to drag it to the right of that point of intersection. You can see it's shaded and it says upper bound now at the bottom. Hit enter again, and there's my point of intersection. Minus 1.31732 is the x value. That's what I'm after. So I could round that to 3 significant figures. So to find the other point of intersection, which is over here, I'm going to repeat the procedure. Hit menu, go to analyze graph, intersection, and you can see the dashed vertical line again. Move it to the left of the point of intersection for the lower bound. Hit enter, and drag it to the right of the point of intersection for the upper bound. Hit enter, and you can just see the x value there. I could move it actually, see it a bit more clearly. It's 1.6757. So those are the two values of x where the two graphs meet, and basically you've solved this now. F of x equals g of x. So f of x equals g of x for these two values of x. And the last bit, part C, write down the set of values of x for which f of x is greater than g of x. Well, again, we need to look at our graphs, so I'm going to look at them on here. And where is f of x greater than g of x? Well, f of x is the red graph, and the y values of the red graph, that is the f of x values, are always greater than the y values of the green graph, the g of x values, between, if you look at inspect the two graphs, between the two x values that we just found, minus 1.317 and 1.6757, because after that you can see the graphs flick around. The green graph, the g of x values will be greater than the f of x values. So the range of values of x for which f of x is greater than g of x is between minus 1.32 and 1.68. That's the two x values that we found earlier on, rounded to 3 significant figures.